Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. Like he said, my name is Amy Sink and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do here on Wednesdays, which is gather together, solve some math problems together, and really help you build that confidence and competence in those math skills. Because y'all, these tests are not easy. I was going to say they're not hard. They are hard. These tests are not easy. And so it is just super, super important to us that you feel that confidence and competence in the math. So like you said, I'm Amy Sink. I am from Central Florida. And I am married. If you're new here, we have a dog named Pudge. We have a little one. And I am an assistant principal here in Central Florida. Before we get started, I always like to do a get to know you. So let me know in the comments where you're from, what test are you prepping for, and the get to know you question this week will be, do you like snow? Why am I asking that? Because Florida had record-breaking temperatures and we actually got snow in Florida. I wish so badly that I lived in an area that got snow. We are obsessed with the cold in our house. I love the cold weather. I would live in the mountains if I could. We love to ski. We love the snow. We love all of it. Unfortunately, in Central Florida, we did not get snow. We got cold, wet rain, but we did not get snow today. But it was, I just wore this to work today. I didn't have a jacket on or anything. And when I was walking through the hallways, my hands felt like they were going to freeze right off of my body. So it is definitely, it's cold, y'all. It's cold. So where are you from? What test are you prepping for? And do you like the snow? Some people are like, I like the snow, but I don't want to shovel it. Okay, you know what? You're right. I don't want to shovel the snow either. So there's that. But where are you from? What test are you prepping for? And do you like the snow? The last time we went skiing, we got snowflakes that fell out of the sky that were like this big. And it was so Ooh, sorry. It was so beautiful. But again, that's like snow, like shoveling snow kind of snow. So that's a little different. I am going to go over problems that are for pre-K through 12. If there's a problem or a set of problems that you're like, man, I wish she would have gone over this. Let me know in the comment box. Find me on Facebook and message me. Find us on our Facebook page, The Learning Liaisons, and tag me. If there is something that you are just wishing that I go over in upcoming weeks, let me know. Not notes, next week. That should say next week. I am happy to include stuff that you specifically ask for because these sessions are for you. I like to tailor them to the needs of you guys. So let me know in the comment box. Hey, Leanne, it is so good to see you. I love when I see familiar faces. Some of my familiar faces have passed their tests and gone on, and they're not with us anymore, which is so sad. I mean, it's not sad. It means that what we are doing is working, but I miss seeing their faces. You're from East Texas, studying for the EC6. A lot of people are studying for that right now, and not a fan of snow. So you like watching the snow from the window, watching how pretty it is. Got it. My husband and I both love the snow. My mom is very much like you, like thinks that the snow is pretty from the window, but she wants to be sitting by the fire with her hot cocoa or her hot coffee with like the fire going. That's her kind of snow too. So I love it. All right, let's go ahead and get started with problem number 1. If you have questions, let me know. I'm happy to answer any questions as we're working together. Let me know what you want to see me do in the upcoming weeks, and we're going to go ahead and get started. Problem number 1. What is the axis of symmetry for a parabola whose equation is y equals 3x squared minus 12x plus 10.53? What is the axis of symmetry for a parabola whose equation is y equals 3x squared minus 12x plus 10.53? So when we're looking at this, they are asking us for the axis of symmetry. The axis of symmetry, so like this is not a problem for everybody, but I like to make sure that everybody gets a little bit of something out of every problem. And so axis of symmetry, let's take a look at that. Let's explore that. If I have a triangle that looks like this, the symmetry, the line of symmetry would be here. And this is for everybody. Everybody needs to understand symmetry. That would be if I drew that triangle symmetrical. Or if I drew, let's actually do this because it should draw it symmetrical for me. Nope. Okay, let's do a square or a rectangle. Okay, I wonder if I have to use the black for it to work. The program should allow me to be able to, there we go. Okay, so the axis of symmetry or the line of symmetry would be right there because I'm cutting it in half. It could also be right here for a rectangle, right? If I fold it in half, it's going to meet exactly. A rectangle does not have diagonal symmetry because when you fold it, those corners end up like jaggedy, but a square does have diagonal symmetry. So when we talk about symmetry, we're looking for a line that cuts that shape or that object exactly in half. And it's the same on both sides. That said, when I'm looking for the axis of symmetry for a parabola, I'm looking for the vertical line that cuts that parabola in half. At what point is it going to cut that parabola in half? The vertex. And it's not going to be an x-intercept. It's not going to be a y-intercept. The vertex is the highest or the lowest point of that parabola. And the vertex is going to be that point at which the parabola gets cut in half. So the vertex of this parabola would be right here. How do I find the vertex of a parabola without graphing it? Because that is going to be a very messy graph just because our y-intercept is messy. Well, vertex can be found by doing x equals negative b over 2a, and then plugging that back in to your f of x function, where b A is attached to the x squared, B is attached to the x, and C is your constant variable or constant value. So if I take this equation and I do negative B is negative 12. Don't get confused by the negative B and then just put negative 12. B is negative 12. So you're doing negative 12 all over 2A is 3. So negative 12, negative times a negative is a positive over 6. 12 over 6 is 2. So the x value of my vertex is 2, which means that the x value of the axis of symmetry is also going to be 2. I almost just plugged that 2 back into my equation for no reason. And sometimes that happens, which is why it's so important to understand what is this question asking of me so that, I am sorry. It was a long day at school. I spoke at our school's assembly period today. And so I did that. And then right from school, I had to take my little one to the doctor, and we didn't get home until like 5:15. And so I am struggling. And when I start to lose my voice, I start yawning a lot. I don't know why, but you can tell I'm starting to lose my voice. So I almost plugged this value back in, but that would have done me nothing. It didn't ask me for the vertex. It asked me for the axis of symmetry. So we want to be careful that we know what the problem is asking for and we're not doing extra work. All right, let's go ahead and look at problem 2. A quadrilateral has coordinates P, negative 2, 3, Q, 4, 7, R, negative 3, negative 5, and S, 6, 0. What is the difference between the slope of lines PR and RS? 8, 5/9, 67/9, or negative 67/40. All right, so a quadrilateral, we don't know what kind of quadrilateral, but we know that the definition of a quadrilateral means that the shape has what? Four sides, has coordinates of blah, 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 blah. Now, I know your first gut instinct is going to be to graph it. Your gut instinct is going to be to do this. Negative 2, 3, and 4, 7, and all of that. However, the accuracy of graphing on a graph that is hand drawn, it's not 100% accurate. Now, if you want to graph it just to see what it looks like, you can. But what did the question ask? Again, it's important to look at what the question is asking. What is the difference? Which means I'm doing a subtraction problem between the slope of lines PR and RS. Do I need to graph this? No. Now, if you're not comfortable finding slope without graphing, you need to be a little bit more comfortable finding slope without graphing. If you're not, and that's your last resort, go for it. Sometimes we just got to use last resort. Sometimes we've just got to use last resort options, right? But how do I find slope? Slope can be found by doing y minus y over x minus x. Now, a lot of times you will see this formula written y2 minus y1, x2 minus x1. Y'all, does it matter if you do y2 or y1 first? No, but it does matter that you follow the pattern. So if you do y1 first, then you have to do x1 first. If you do y2 first, then you have to do x2 first. Does all of that make sense? So What's the difference between the slopes of lines PR and RS? So PR, -2, 3, -3, -5, and RS, -3, -5, and 6, 0. I need to find the slope of both of those lines. Then I need to find the difference of it. So I need to find the slope of both of those lines, and then I need to find the difference between those slopes. So I'm going to do y minus y over x minus x. I'm going to start with -5. Why? I don't know. You can start with 3. It doesn't matter. -5 minus 3. Why? Because this is my x and this is my y. This is my x and this is my y. So my y's go on top because remember, slope is rise over run, which means I'm doing my y's over my x's. Now, because I did this guy first, I have to do this guy first. -3 minus -2 equals -5 minus 3 is -8. -3 minus -2 becomes a plus. -3 plus 2 is -1. So this becomes a +8. Now let's do RS. Y minus y, x minus x. I'm going to start with this one this time. -5 minus 0, which means I have to start with this one on the bottom, -3 minus 6. -5 minus 0 is just -5. -3 minus 6 is -9. So this becomes 5 ninths. Now, what is the difference between PR and RS? I'm going to do 8 minus 5 ninths. How do I do 8 minus 5 ninths? I know my answer is not going to be A, and I know my answer is not going to be B, because A is 8 and B is 5 ninths, and I need to subtract them. This part is for everybody. Elementary people, you need to know how to subtract whole numbers and fractions. So how am I going to do that? Make them common denominators. How do I get them to be common denominators? Multiply this by 9 over 9. You got it, because I want them to be ninths. 9 times 8 is 72. Minus 5 ninths. 72 minus 5 is 67. So my answer is 67 ninths. Questions about that problem? Hey, Hope, it is good to see you, my friend. Let's go ahead and move on to problem number 3. When these numbers are ordered on a number line, which is closest to the number -1? When these are ordered on a number line, which is closest to the number -1? All right, so when I look at these numbers, I see 103%. I see -0.975. I see -1 and 23/24, and I see 9/10. And we are looking for the number that is closest to -1. So 103% is going to equal 1.03. And you say, wait a minute, how did you just get that? Well, to convert a percent into a decimal, all I'm going to do is place an imaginary decimal if I don't see one, and I'm going to hop it to the left 2 times. Hop, which gives me 1.03. That places this number like over here. Is that anywhere close to -1? my target number? No. Negative 0.975. So I'm going 0, negative 0.1, negative 0.2, negative 0.3, negative 0.4, negative 0.5, negative 0.6, negative 0.7, negative 0.8, negative 0.975, and then 1 whole. That's pretty dang close. 9/10. This is going to be super close to the number 1, not the number -1. It's on the positive side. And I already have a negative number on the negative side that's close to the number -1. So I'm not going to even entertain that as an idea. So I know these are out. -1 and 23/24. Where is that going to be on this number line? This is going to be really close to -2. This is going to be really close to -2. So my answer is going to be B. Good job, Hope. All right, let's move on to problem number 4. Charity is putting a pool and garden in her backyard. The design can be seen below. How much larger is the square footage of her pool than her garden? How much larger is the square footage of her pool than the garden? So let's look at the question before we start to solve. How much larger is her pool than the garden? Even though this doesn't say what is the difference, this phrasing tells me that I'm looking for that gap in between the pool and the garden, which means I'm doing some sort of subtraction problem. And they're looking for the square footage. What does that mean when I'm looking for the square footage? I'm looking for area. So I need to find the area of the pool and subtract the area of the garden from it. Well, area of the pool is super duper simple, y'all. Area of the pool is just a rectangle. So what is the area of a rectangle? Length times width. That's something everybody needs to know. Area of a rectangle is length times width. So I can do 8 times 12, and that's going to give me, I should probably have that memorized, but this brain's not working like that today. 96. 8 times 12 is 96. Now I need to find the area of this triangle right here. What is the formula for area of a triangle? What is the formula for area of a triangle? 1/2 base times height. 1/2 base times height. Well, my base is going to be 8. Because if this side of the rectangle is 8, then this side of the rectangle is going to be 8. But they didn't give me this side, and they didn't give me this height. So what am I going to do? I know I'm going to end up with area equals 1/2 base times, what is that height value? When you get stuck in something like this is when I like to look at the problem and go, okay, what other information have they given me that I haven't used yet? What other information have they given me that I have not used yet? Well, they gave me this 22 value right here. what am I going to do with that? Well, if this from here to here is 12, then what is this missing part? This is your part, whole. Your whole is 22. One part is 12. What is the other part? I can do 22 minus 12, and that gives me 10. So this distance right here is going to be 10. Half of 8 is 4 times 10 equals 40. But I'm not done yet. And that's why it's important for you to kind of sketch out what that final step is going to be, because it would be very easy to choose 40 because it's over there. And when you're stressed and you're heightened and you're like, I don't know what I'm doing, it's easy to fall into that trap. I need to take area of my pool and subtract area of my garden, which equals 56 feet squared. Questions about that? All right, let's go ahead and move on to problem number 5. Y'all are doing good tonight. Goodness. Problem number 5. On a 2,000-mile road trip with 4 of her friends, Betsy determines her SUV consumes 15 gallons of gasoline for every 250 miles traveled. If the average cost of gasoline is $3.15 per gallon, how much in dollars will each person pay if they are splitting the gasoline bill evenly? Tasha, great question. I am so glad that you asked that question. Let me go ahead and go back because I haven't really started this problem, and we'll come back to this problem. You said, why did you place the 8 there? I'm guessing you're asking about this 8 right here. Am I correct? If I'm not, correct me. But I put the 8 there so that I could see what the value of my base was for this triangle. Because if I flip that triangle around and I needed to find the area, I need to do 1/2 base times height. The height is that dotted line, and the base is this guy right here, which is 8. And I know in a rectangle that this side is going to be equal to this side, and the top is going to be equal to the bottom. That's just the property of a rectangle. So if this side is 8, and that's something that they gave us, then this side is also going to be 8. I think that's what your question was. If it's not, please, please, please clarify, and I will come back to this, okay? All right, let's go ahead and keep going with this 2,000-mile road trip. All right, so they're on this 2,000-mile road trip with 4 friends. Betsy determines that her SUV consumes 15 gallons of gas for every 250 miles traveled. So if this is my road, there's my car, and this is the 2,000-mile mark, right? Every 250 miles they travel, they use 15 miles of gas. Every 250 miles they travel, they use 15 miles of gas, okay? So if I cut this in half, this would be 1,000 because that's 2,000. And how many 250s are in 1,000? 4, right? 250, 500, 750, 1,000. And then it's going to be the same thing. So there's going to be 4 250s in 1,000, right? Which means every time they travel 250 miles, we are filling up with 15 gallons of gas, 15 gallons of gas, 15 gallons of gas, 15 gallons of gas, 15 gallons of gas. So how much gas has this car used from the start to the finish, assuming that it started with a full tank? All of these 15s, which is 15 times 1, 2, 3, 4, 5, 6, 7, 8. 15 times 8 is going to give me the gallons of gas used. Now, I am going to write that out even if this was my test because I want to make sure I don't get lost in the muddle of doing this problem. So I am going to go ahead and do that in the calculator. $15 times 8, that's 120 gallons of gas used. The average cost of gasoline is $3.15 per gallon. So if it's per gallon, each gallon is $3.15, then I can take 120 and multiply it by $3.15. And that's going to give me my total cost of gas. That equals 378. Now what? The question asked, how much will each person pay? Each person pay if they split the bill evenly. Each person. So 378 divided by what? Yes, divided by 5. The trick here is that it says 4 of her friends, but we are not dividing by 4 because Betsy is on this road trip too. And so if they are on the road trip together, Betsy's going to pay for some gas too. So we need to divide it by 5, which equals $75.60, which is A. Excellent, excellent job. I thought I was going to trick you with that one, but clearly I did not. All righty. Let me know if you have any questions about that, and let's go ahead and move on to problem number 6. A circle in an XY plane has a diameter with endpoints 1, 4 and 1, 16. An equation of this circle is x minus 1 squared plus y minus 10 squared equals r squared, where r is a positive constant. What is the value of r? What is the value of r? All right. So there's a couple of different ways that we can approach this. We can rough sketch this graph. So let's go backwards. Here's the equation. Right? There's the equation. And in an equation of a circle, this is the center of your circle right here. So the raw equation of the circle is x minus h squared plus y minus k squared equals r squared, where hk is your center. So the signs are kind of like opposite of what you would expect. So the center of this circle is 1, 10 over 1 up 10. And we have endpoints of a diameter at 1, 4 and 1, 16. So like way up here, right? And then that creates our circle, right? And r is a positive context. R is a positive constant. What is the value of r? So r is the radius. They didn't ask for r squared. They asked for r, and r is the radius. Man, if you're around with me at any point for Math Wednesday, you know that we just sometimes disconnect, and that's okay. And I thought we were going to make it through for this entire Math Wednesday, but it didn't happen, so I have to reconnect before we keep going. All right. Here we go. So I'm trying to figure out what R is, which is my radius. Now, in this situation, I can pretty clearly see, and especially if I had grid paper or something, I can see that my endpoints and my center all lined up exactly vertically. However, if they gave you a circle and they gave you points that were like something like this, and you couldn't just count them, you would have to use the distance formula. So if you're trying to find R, rather than doing the distance between these 2 points and then dividing by 2, if they give you the center, you can just do the distance between the center and the end point, and that'll give you your R value. And what is the distance formula? The distance formula is D equals the square root of x of y minus y squared. Wait, now I'm confusing myself. Distance formula. I'm having to like look it up super fast. I knew I was right. X minus x squared plus y minus y squared. Distance equals x minus x squared plus y minus y squared. So I can, if my circle is not exactly vertical or exactly horizontal, I can do distance equals x minus x plus y minus y. If it's like what we were given, then we can just count, right? We can count between 4 and 10 and figure it out. What's the distance between 10 and 4? 10 minus 4 is 6. So R is 6 in this case. But if it's not easy to count, then you have to do the distance formula. Does that make sense? Questions, comments, concerns? Don't forget to let me know what you want to see from me in the upcoming week. I have a next week section, so let me know so that I can add like different topics and stuff into the next week section. Sound good? All right, let's go ahead and move on to problem number 7. The perimeter of an equilateral triangle is 384 centimeters. The height of this triangle is k square roots of 5 centimeters, where k is a constant. What is the value of k? Ooh, this one is so fun, y'all. I love this one. So, first of all, we need to know what an equilateral triangle is, right? So everybody should know that. Like, there are some things that like not everybody needs to know. Like, not everybody's going to need to know how to solve this problem, but all of my people need to know what is an equilateral triangle, right? So I'm going to draw myself an equilateral triangle. Drawing myself an equilateral triangle. That's not an equilateral triangle. Drawing myself an equilateral triangle. We're going to call that an equilateral triangle. So, and the perimeter is 384. So the distance between all 3 points is 384. Equilateral means all 3 sides the same. The height is k square roots of 5, where k is a constant. What is the value of k? If the perimeter is 384, then I can do 384 divided by 3 to figure out each side, right? I can do 384 divided by 3. 384 divided by 3 is, this side is 128, this side is 128, this side is 128. And I can do 128 divided by 2 to kind of figure out what each of these sides is, right? Now, what else do I know about an equilateral triangle? What else do I know about an equilateral triangle? I know that the angles all equal 60 degrees. So if this is 60 and this is 60, then this has to be 30 and 30, right? Because my 60 is being cut in half. And the height is always going to drop down and create a 90-degree angle. So what I've just created is a 30, 60, 90-degree triangle. Interesting, huh? And what do I know about the relationship of a 30, 60, 90-degree triangle? I know that this is x across from the 30. I know across from the 90 is 2x. And I know across from the 60 is x square roots of 3. Right? So if x is 64, following, x equals 64 because 2x equals 128, then x square roots of 3 would be 64 square roots of 3 is what this side is. But they're telling us that it is k square roots of 5. So what I need to do is, because I've now found the value of this side, I need to do 64 square roots of 3 equals k square roots of 5. And I need to get k by itself. Divide both sides by the square root of 5. K equals, now I can't leave a square root on the bottom, so I have to multiply the bottom by the square root of 5 and the top by the square root of 5, because anything times it, like the square root of 5 divided by the square root of 5 is a value of 1. Anything times 1 is itself. So I have 64 square roots of 15 divided by 5. Now, the answer is technically B. Here's what I did, and here's what I would caution you on. When I was originally creating this problem and solving it, I used 128 as the bottom of my 30, 60, 90-degree triangle. And that was a big error on my part because it gave me the wrong answer. And I'm actually kind of glad that it happened because it allowed me to show you the errors that were made, right? I made an error in solving this problem the first time that I did it. And now you can kind of see what that error was so that you can start to look for those errors when you're solving problems. All right, we're getting ready to kind of wind down, close down. We have time for 1 or 2 more problems. Begin to think about what you want to see me go over in the upcoming weeks. I'm going to go ahead and get ready to solve the next problem, but start to think about that so that before we're done, you can let me know, hey, Amy, will you go over this next week? I will be happy to do so. Problem number 8. In the figure to the right, A is the center of the circle. Which of the following must be true? Which of the following must be true? AB and AC are perpendicular to each other. Triangle ABC is an equilateral triangle. AB and AC are congruent. AC and BC are congruent. So we're not talking about which of the following could be true. We're talking about which of the following must be true. If A is the center of the circle, then any line that extends out and touches the end of the circle is going to be a radius. And all radius are going to be equal to one another. So that means that this line and this line are equal to each other. Does it mean that this line is also equal? No. Could it be equal? Sure. Could it be a Equilateral triangle? It could. Could AB and AC be perpendicular? It could, absolutely. But none of those are 100% definite. The only thing that's 100% definite is that AB and AC are congruent. They are equal because they are radius. AC and BC do not have to be congruent because this is not a radius. They don't have to be perpendicular. And it could be an equilateral triangle, but there's nothing in this problem that's proving that. Now, if they said A is the center of the circle and angle BAC is equal to 60 degrees, then I would know that BC is equal to all of those, because if these sides are congruent and this is 60 degrees, that tells me that this is also 60 and this is also 60, because those angles have to be the same because those sides are the same. So all of that would go ahead and prove that BC is also equal, but it didn't give us any of that information. So therefore, C is the correct answer. Questions about that? All right, let's go to the next problem. Shown to the right are line segments AB and CD. Which of the following is true about these two line segments? They are perpendicular lines. They are parallel lines. They are intersecting lines that are not perpendicular. CD has a negative slope and AB has a positive slope. So they're asking which of the following is true. Are they perpendicular? Are they parallel? I know they're not parallel because they are intersecting. Parallel lines always do not intersect. Like if I have parallel lines, they're not going to intersect. They are intersecting lines that are not perpendicular. Could be perpendicular. Haven't proven it yet. CD has a negative slope. Absolutely not. CD has a positive slope. That right there is a positive slope. So I know D is wrong. How do I know it's a positive slope? Because I read from left to right, just like I read words from left to right. And so when I catch this graph, it's going up. When I catch this graph, it's going down. So I know AB is negative and CD is positive. So D is not correct. So really at this point, I'm just figuring out if they're perpendicular or if they're just intersecting lines that are not perpendicular. How do I go about doing that? Find the slope. I'm going to find where it intersects with my grid. So there's an intersection. Okay, so it looks like we've got intersections all the way up. And then over here, so what's the slope of CD? Rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. So CD has a slope of rise 2, run 1. AB has a slope of go down 2 over 1, down 2 over 1, down 2 over 1. Are those perpendicular? They are not perpendicular. Parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. So if this is the slope of CD, then AB would have to be negative B over A. And in this case, it's AB and negative AB. So these are just intersecting lines that are not perpendicular. Let's look at another problem similar. So it's the same set of lines, but it's having us think a little bit differently. What change would need to happen to make these lines perpendicular? So if I go back over here and I copy this and paste it here, because it's the same problem, we're just thinking about it a little bit differently. What would have to happen to make these lines perpendicular? The change in x's. Now remember, slope is y minus y over x minus x, right? So change in y over change in x. So the change in x's for line AB would need to increase by 4. So the change in x for AB would need to increase by 4. So add 4 to the bottom here. So that would give me negative 2 over 5. Are those perpendicular? No. The change in y for CD would need to increase by 3. 2 plus 3 is 5. 5 over 1. Is that going to be it? No. The change in y for line AB would need to decrease by 4. Negative 2 minus 4 would be negative 6 over 1. Does that give me perpendicular lines? No. The change in x for line CD would need to decrease by 3. 2 minus 3 is negative 1 over 1. Awesome. So none of these worked. I changed this problem today. So let's see what would work. Negative 1 over 1. If this was increased by 3, that would be the right answer. Let's look at that. The change in x's for line AB would need to increase by 3. If I increase this by 3, I would get negative 2 over 4, which would equal negative 1/2. And that would be perpendicular lines. So that would be the right answer. All right. Questions, comments, concerns? Let me know in the comment box what you want to see me go over in the upcoming weeks. I'm going to turn it back over to Dr. A, but we will absolutely see you next week. And maybe it won't be snowing in Florida anymore. That would be sad, but I'm hoping we get snow here in Florida, in Central Florida. I don't think it's going to happen. I think we're too far south, but I hope you have a great week. I hope you have a great weekend, and I will see you next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.